In this video, we are going to talk about solving systems algebraically. So if I look at this first question, number 1, I can see that y is equal to 3x, so then I can substitute 3x in for y in the first equation. So what I'm going to do is I'm going to have x squared minus 3x equals 4, because again, I'm replacing y with 3x. Now distributing that negative into the 3x, I'm going to have x squared minus 3x equals 4. Now, since this is a quadratic equation, I want it equal to 0, so that way I can solve. So I'm going to end up with x squared minus 3x minus 4 equals 0. Now, in order to factor this, since it's a trinomial, I'm going to think about what multiplies to negative 4 and adds to negative 3. And so what multiplies to negative 4 and adds to negative 3 is negative 4 and positive 1. Now my solutions always come from the opposite of my factors. So x minus 4 means one of my solutions is positive 4. X plus 1 means one of my solutions is negative 1. Now these are just my x solutions, so these are only half of each of my solutions. So remember, our solutions are always x comma y. So I have x comma something and x comma something. Now I need to plug these back in order to solve for y. So I'm going to use the second equation because it's y equals 3x, and I'm going to plug in 4, and I would get 12. So 4, 12 is one solution. Then I'm going to do the same thing, but with a negative 1, and I'm going to get negative 3. So then my other solution is going to be negative 1, negative 3. Similarly, in number 2, I can see that y is equal to 2x minus 3, so I'm going to substitute that in for y. So I'm going to end up with x squared minus 4 times 2x minus 3 is going to equal 0. I'm going to distribute that negative 4, and I'll get negative 8x plus 12 equals 0. Now this equation is already equal to 0, so I can go straight into what multiplies to 12 and adds to negative 8. And so it's going to be negative 6 and negative 2. So my solutions for x are going to be 6 and 2. Again, just like with number 1, these are only half of each of my solutions. They're the x-coordinate. I need to find the y-coordinate. So I'm going to do that by plugging into that second equation again, because the second equation is already solved for y. So I'm going to have y equals 2 times 6 minus 3. 2 times 6 is 12, minus 3 is 9. Now I'm going to plug in 2. 2 times 2 is 4, minus 3 is 1. And so those will be my solutions for number 2. We're going to skip to number 4. And we're going to have a similar scenario where I have y is equal to negative x minus 7. So I'm going to substitute that in for y. So that'll look like x squared plus negative x minus 7 squared equals 25. Now remember, when you have a quantity squared, that means you have 2 of them. So I'm going to have negative x minus 7 times negative x minus 7. Still with this x squared at the beginning and this 25 at the end. Now to multiply this out, there's 2 ways. One is to distribute. So I could do negative x times negative x, which would give me x squared. Negative x times negative 7, which would be positive 7. Negative 7 times negative x is also positive 7x. And then negative 7 times negative 7 is positive 49. Another way to solve this is by using the box method that we talked about back in Unit 3. And so I could put negative x minus 7 and negative x minus 7. And in my box, I'm going to multiply. So negative x times negative x is x squared. Negative x times negative 7 is 7x. Negative x times negative 7 is 7x. And then negative 7 times negative 7 is 49. Notice I got the same numbers in my box as I did when I multiplied it out. So either way, we need to multiply that out. So whatever method you choose is up to you. So I'm going to bring down this x squared from the beginning, put this 25 at the end. Now I need to combine some like terms. So I have x squared plus x squared. So now this is like 1x squared plus 1x squared is going to give me 2x squared. Then I have 7x and 7x. So if I add those together, I'm going to get 14x plus 49 equals 25. Now, like we talked about in number 1 and in number 2, my equation needs to be equal to 0 in order to solve. So I'm going to subtract 25. And so I'll get 2x squared plus 14x plus 24 is equal to 0. Now if you notice, all three of my terms are divisible by the leading coefficient of 2. So I'm going to divide everything by 2, and what that'll give me is x squared plus 7x plus 12 is equal to 0. Now this is going to be much easier to solve because the numbers are a lot smaller. So now I need to think about two numbers that multiply to 12 and add to 7. And so the two numbers that multiply to 12 and add to 7 are positive 4 and positive 3. So my two x solutions are going to be negative 3 and negative 4. Or sorry, negative 4 and negative 3. Now I'm going to need to plug those back in to solve for y. So I'm going to use that second equation, and I'm going to put in negative 4 with a negative x, so that'll give me a positive 4 minus 7 is negative 3. All right, and then I'm going to do negative 3 minus 7, same idea, positive 3 minus 7 is negative 4. And so this will be my solution for number 4. In number 5, I do not have either variable solved for, so I'm going to get the x alone by adding y, and what that'll do is I'll change this equation into x equals y. This will allow me to substitute y in for x. And so I'm going to end up with y squared plus y squared equals 18. Well, this is like 1y squared plus 1y squared. So this is 2y squared is going to equal 18. Now, this is still a quadratic equation because it has that squared, but I don't need to make it equal to 0 because I just have the one variable. So I'm just going to finish solving this by dividing by 2, and then when I have a squared to get rid of a squared, I'm going to square root. Now be careful, when you square root, you have to remember you get two solutions. So I'm going to get positive and negative 3. So when I go to write my answer, I'm going to have something comma 3 and something comma negative 3. So remember, we just solved for y, so that's why I'm putting the 3 and the negative 3 in the second spot. Now, unlike the other ones, I need to now plug in for y and solve for x. So I'm going to use this x minus y equals 0 equation. And I'm going to plug in 3 for y, because that's what I got for my first solution here. And when I do that, I'm going to get that x equals 3. I'm going to do the same thing now, but I'm going to plug in the negative 3 for y. And I'm going to get that x is negative 3. And so these are my two solutions for number 5. In this last equation in number 6, this is similar to kind of the first couple where my y is alone. So I have y equals x plus 2. So I'm going to substitute that in for y. So what that'll look like is I have x plus 2 quantity squared plus x plus 2 minus 2, because here's y and then here's the minus 2, and it's going to equal 4. So if I have x plus 2 quantity squared, again, that means I need to do x plus 2 times x plus 2. So whether I multiply that out or whether I do the box method over here on the side, I need to multiply those two together. I'll do that in a second. In the second parentheses, I have minus 2 and plus 2, so I'm just going to have x plus 0, so just x squared. So when I go to multiply this part out, x times x is x squared, x times 2 is 2x, 2 times x is 2x, 2 times 2 is 4, plus x squared is going to equal 4. Now again, if I were to use the box method, I would get the same thing. X times x is x squared, x times 2 is 2x, x times 2 is 2x, 2 times 2 is 4. So now I need to combine some like terms. So I have x squared and x squared, so I'm going to have 2x squared. 2x and 2x is 4x, plus 4 equals 4. Now, it looks like I'm going to have a trinomial on this left side, so I know my equation needs to be equal to 0 before I can solve. But what's going to happen is this 4 is also going to add to 0. So I'm going to end up with 2x squared plus 4x equals 0. Now, this is a special type of factoring relating to GCF. So I want to think about if I have 2 and 4, well, the biggest number that I'll divide both of those is 2. And if I have x squared and x, I'm going to divide both of those by x. So I'm going to have 2x on the outside, and then x plus 2 left on the inside. Because when I do 2 divided by 2 and x squared divided by x, I'm left with x. 4 divided by 2 is 2, and x divided by x will divide. How to solve this? I'm going to set each of these equal to 0. And I'm going to get -2 and 0. So I'm going to have 0 comma something and -2 comma something. Now I need to plug these back in. I'm going to use the second equation to solve for y. So I'm going to have 0 plus 2, well that's 2. And then -2 plus 2, and that is 0. And so those will be my two solutions for number 6.